Assalamualaikum warahmatullahi wabarakatuh. So today I'm going to present our group chemistry assignment, which is group number 4. Our group is discussing about aromatic compound that we had learned in chapter 6. My name is FATIN binti Muhammad HISHAM. I'm a first presenter in our group. So let me get started with introduce another member in this group. Our group consists of 5 members, which are Nur Hidayati binti AZLI, Muhammad NABIL Atif bin Muhammad Noor, Nur SUHANA binti SAAT, and Nur SYAFIAH binti ADNAN. For the first question that had been given in this assignment is by using appropriate equations and stating the type of mechanism involved, explain why benzene is less reactive than cyclohexane towards chlorination. Okay, for answering this question, we need to provide 2 equations, which is benzene and cyclohexanes towards chlorination, and we need to explain why benzene is less reactive than cyclohexane. Okay, for the first equation, which is benzene towards chlorination, in the presence of FeCl3, it produces chlorobenzene as a major product, and the type of mechanism is electrophilic aromatic substitution. For equation cyclohexane toward chlorination, in the presence of CH2Cl2, it produces a 1,2-dichlorocyclohexane. And the type of mechanism is electrophilic addition of alkenes. For the last requirement in this question is why benzene is less reactive than cyclohexane towards chlorination. Benzene less reactive with electrophilic, which is chlorine Cl2, because the delocalized pi system has a lower electron density than localized pi bond in the C-double-bond-C.
Okay, so the question is benzene. Benzene can undergo Friedel-Crafts acylation with ethanoic chloride to form compound A. So write the reaction equation and name the compound A. So benzene, when reacts with ethanoic chloride in the presence of AlCl3, which is the Lewis acid as the catalyst, and the heat, the carbon and the Cl bond will be broken, and the acyl group will attach to the benzene ring and form the aromatic ketone, which is phenylethanol. The reaction mechanism, including the formation of resonance structures for the rhenium ion. So firstly, the step 1 is generation of electrophile. So the acyl chloride is going to react with the AlCl3, which is the catalyst. So Cl has 3 lone pairs electron on it, and aluminium will attract the Cl and cause the acyl chloride to be bonded together, and it will become like this, the intermediate. So the Al has negative charge on it, and the Cl has positive charge on it. Cl will move out from the intermediate because Cl is more electronegative than the carbon, and the electron between the carbon and the Cl bond will be given to the aluminium, and we will get the electrophile, which is COCH3+, and the side product, which is AlCl4-. The second step is the formation of rhenium ion. So we have benzene ring and we have the electrophile, which is COCH3+. The benzene ring is a nucleophilic site, and it will be attacked by the electrophile to form an rhenium ion. So rhenium ion now has COCH3 attached to the carbon with the same carbon with H. So this double bond is used to make bond with COCH3+, and it will cause this bond, this carbon to become positive and lost one of the bond. So from here we can show the formation of structures, resonance structures of rhenium ion. Firstly, we have to redraw the resonance structure of the rhenium ion. So this carbon has positive charge, and the electron in the double bond will keep moving. So the electron in this bond will move to this point to make this positive charge becomes neutral, and it will form a resonance structures where the double bond now is moving to this one. So it will move to this one and cause this carbon to become positive charge and lost one of the bond. So the last part is this bond will move to this bond and it will cause the same thing, which is the carbon will lose one of the bond and it will become positive charge. Okay, so the third step is loss of proton to reform the aromatic ring. So firstly, we use the first resonance structure in step 2 just now and the structure of AlCl4- in the step 1. In the step 1, to reform the aromatic ring. So Cl is attacked by the H+, and this bond will be given to the ring, and we have given back the aromaticity of the benzene ring, which form a stable product, which is called phenylethanol back, and form HCl as the byproduct, and we gain back AlCl3 as the catalyst.
Next question is suggest a synthetic pathway to show the formation of phenylmethanamine from benzene. So first of all, benzene needs to undergo process alkylation in the presence of lauric acid. The lauric acid that we use in this process is AlCl3 to form toluene, and then toluene will undergo process halogenation under UV to form benzene chloride plus NH3 excess. Lastly, benzene chloride will undergo process dehydrohalogenation in the presence of alcohol and reflux to form phenylmethanamine.
Assalamualaikum warahmatullahi wabarakatuh. I am Nur Syafia Syuhaidah binti ADNAN and I am going to explain the next question, which is compound A reacts with a hot mixture of concentrated nitric acid and concentrated sulfuric acid to form only one product. Draw the product produced. So first we draw the compound A and add with the acid nitric and also the concentrated sulfuric acid, and then we will get the M-nitroacetophenone, or we call M-nitrophenylethanol, and also we will get the product water. Okay, so now we move to the next question, which is explain why only one product is produced. The reason why only one product is produced because POCH3 is EWG or electron withdrawing group, which is a deactivating meta director that tends to direct the incoming group into meta position.
For task 2 iNet component, the functional group presented in our chosen plant, which is olives, is aromatic ring. So the related Quranic verse based on the plant that we choose is from Surah At-Tin, verse number 1. A'udzubillahi minasyaitonirrajim. Wat-tini waz-zaitun. So, one component in the olives is benzene or olive oil, occurs naturally in the olive tree, and it is also produced synthetically. So the benzene contains the functional group aromatic ring, just like I mentioned before. So the structure is shown above. This is the structure of benzene on top of the slide. Next, the composition of the plant. One serving of 15 grams to 20 grams per serving of olives actually provides about 30 calories, 80% of water, 15% of fat, which is primarily monounsaturated fat. One serving of olives also contain 1.25 grams of carbohydrate, 0.7 grams of fiber, 0.15 grams of protein, and lastly 0.5 grams of salt. The olives also contain micronutrients such as vitamin E, copper, and calcium. Lastly, benefits of the plant. Like I mentioned before, that olives actually contain vitamin E, copper, and calcium. So, for vitamin E, it is a powerful antioxidant that helps protect our cells from oxidative damage. And there is also evidence that this vitamin actually may play a role in obesity. So, next, copper plays an important role in heart health, reducing the risk of heart disease such as heart attack. So, lastly, calcium is an essential for regulating muscle contraction and making sure our blood clots normally.